Drinking birds, also known as insatiable birdies or dipping birds, are toy heat engines that mimic the motions of a bird drinking from a water source. They are sometimes incorrectly considered examples of a perpetual motion device. Construction and materials: a drinking bird consists of two glass bulbs joined by a glass tube. The tube extends nearly all the way into the bottom bulb, and attaches to the top bulb but does not extend into it. The space inside the bird contains a fluid, usually colored. The fluid is typically dichloromethane, also known as methylene chloride. Earlier versions contain trichlorofluoromethane. Air is removed from the apparatus during manufacture, so the space inside the body is filled by vapor evaporated from the fluid. The upper bulb has a beak attached which, along with the head, is covered in a felt-like material. The bird is typically decorated with paper eyes, a plastic top hat, and one or more tail feathers. The whole setup pivots on an adjustable crosspiece attached to the neck. Despite the drinking bird's appearance and classification as a toy, some safety considerations additional to the potential danger of thin shards of glass apply should the bulb break. Early models were often filled with highly flammable substances, though the fluid in later versions is non-flammable. Dichloromethane can irritate the skin on contact and the lungs if inhaled. Operation: the drinking bird is a heat engine that exploits a temperature difference to convert heat energy to a pressure difference within the device, and perform mechanical work. Like all heat engines, the drinking bird works through a thermodynamic cycle. The initial state of the system is a bird with a wet head oriented vertically. The process operates as follows: the water evaporates from the felt on the head. Evaporation lowers the temperature of the glass head. The temperature decrease causes some of the dichloromethane vapor in the head to condense. The lower temperature and condensation together cause the pressure to drop in the head. The higher vapor pressure in the warmer base pushes the liquid up the neck. As the liquid rises, the bird becomes top-heavy and tips over. When the bird tips over, the bottom end of the neck tube rises above the surface of the liquid. A bubble of warm vapor rises up the tube through this gap, displacing liquid as it goes. Liquid flows back to the bottom bulb, and pressure equalizes between the top and bottom bulbs. The weight of the liquid in the bottom bulb restores the bird to its vertical position. The liquid in the bottom bulb is heated by ambient air, which is at a temperature slightly higher than the temperature of the bird's head. If a glass of water is placed so that the beak dips into it on its descent, the bird will continue to absorb water and the cycle will continue as long as there is enough water in the glass to keep the head wet. However, the bird will continue to dip even without a source of water, as long as the head is wet, or as long as a temperature differential is maintained between the head and body. This differential can be generated without evaporative cooling in the head. For instance, a heat source directed at the bottom bulb will create a pressure differential between top and bottom that will drive the engine. The ultimate source of energy is the temperature gradient between the toy's head and base. The toy is not a perpetual motion machine. An analysis showed that the evaporative heat flux driving a small bird was about half a watt, whereas the mechanical power expressed in bird's motion was about 1/20,000 of a watt. The system efficiency is about 0.01%. More practically, about 1/1,000,000 of a watt can be extracted from the bird either with a coil magnet setup or a ratchet used to winch paper clips. Alternative operation: a dunking bird of the second kind was introduced, which, while similar to the original drinking bird, will operate without a temperature difference. Instead it utilizes a combination of capillary action, gravitational potential difference and the evaporation of water to power the device. Such a bird works as follows: it is balanced such that, when dry, it tips into a head-down position. The bird is placed next to a water source such that this position brings its beak into contact with water. Water is then lifted into the beak by capillary action and carried past the fulcrum. When enough water has been absorbed by the device, the now heavy bottom causes the bird to tip into a head-up position. With the beak out of the water, eventually enough water evaporates from the sponge that the original balance is restored and the head tips down again. Physical and chemical principles: The drinking bird is an interesting exhibition of several physical laws and is therefore a staple of basic chemistry and physics education. These include, the dichloromethane with a low boiling point of 39.6 degrees Celsius, gives the heat engine the ability to extract motion from low temperatures. The drinking bird is a heat engine that works at room temperature. The combined gas law, which establishes a proportional relationship between temperature and pressure exerted by a gas in a constant volume. The ideal gas law, which establishes a proportional relationship between number of gas particles and pressure in a constant volume. The Maxwell-Boltzmann distribution, which establishes that molecules in a given space at a given temperature vary in energy level, and therefore can exist in multiple phases at a single temperature. Heat of vaporization, which establishes that substances absorb heat when changing state at a constant temperature. Torque and center of mass. Capillary action of the wicking felt. Wet bulb temperature. The temperature difference between the head and body depends on the relative humidity of the air. History. A Chinese drinking bird toy dating back to 1910s to 1930s named insatiable birdie is described in Yakov Perelman's Physics for Entertainment. The book explained the insatiable mechanism. Since the head tube's temperature becomes lower than that of the tail reservoir, this causes a drop in the pressure of the saturated vapors in the head tube. It was said in Shanghai, China, that when Albert Einstein and his wife, Elsa, arrived in Shanghai in 1922, they were fascinated by the Chinese insatiable birdie toy. In addition, the Japanese professor of toys, Takao Sakai, from Tohoku University, also introduced this Chinese toy. The drinking bird was patented in the U.S. by Miles V. Sullivan in 1946. He was a Ph.D. inventor-scientist at Bell Labs in Murray Hill, New Jersey, USA. Notable usage in popular culture. The drinking bird has been used in many fictional contexts to automatically press buttons. In The Simpsons episode King Size Homer, Homer used one to repeatedly press a key on a computer keyboard. Two of them were used in the 1990 film Darkman to set off explosions. Drinking birds have appeared as part of a Rube Goldberg machine in the film Pee-wee's Big Adventure and the Family Guy episode 8 Simple Rules for Buying My Teenage Daughter. Drinking birds have been featured as plot elements in the 1951 Merry Melodies cartoon Putty Tat Trouble and the 1968 science fiction thriller The Power. They have also had minor appearances in several movies and TV shows, including the Woody Allen movie Sleeper, the 1979 science fiction film Alien, the 1989 comedy When Harry Met Sally, the 2008 film Max Payne, the 2010 film Megamind, and episodes of the American TV shows The Simpsons, Mad Men, and Ed, and Eddie. Episode 508 of Mystery Science Theater 3000 features a spoof of the drinking bird called the bobbing buzzard, which runs on carrion instead of water. Among video games, the drinking bird appeared as the Dunkin' Dragon in the Sierra game Quest for Glory, in the Gremlin interactive game Normality, and is a water bird furniture item in the Animal Crossing games. Porygon 2, a poker copyright mon introduced in Generation 2 resembles a drinking bird, and in 3D poker copyright mon games it moves its head in a dipping motion. More recently in the game Quantum Conundrum, one of the main gameplay mechanics is a drinking bird that is used as a timer to press buttons. In the 2014 Creative Assembly video game Alien, Isolation, drinking birds are frequently seen on desks across the game's main setting, Sevastopol Station. In Australian contemporary playwright John Romerill's play The Floating World, drinking birds are a symbolic prop which represent the progression of Les's insanity. They are referred to as dippy birds, and are perhaps used to symbolize such a thing due to Romerill's opinion of drinking birds being that they are insane for their uselessness and repeatability. Mathematical modeling and practical thermodynamics analysis. By considering the difference between the wet and dry bulb temperatures, it is possible to develop a mathematical expression that allows us to calculate the maximum work that can be produced from a given amount of water drunk. Such analysis is based on the definition of the Carnot heat engine efficiency and the psychrometric concepts. See also, Minto wheel, thermodynamics. References. External links, Moriarty, Philip. The Drinking Duck. 60 symbols. Brady Heron for the University of Nottingham.